Mars has always captivated us, hasn't it?
Yeah.
Our cosmic neighbor, promising secrets about the origins of life and how planets evolve.
Well, it really has.
For decades, it's felt like a place just out of reach, yet, constantly inspiring our imagination.
Absolutely. And at the forefront of trying to unlock those Martian secrets is the Mars Sample Return Mission, MSR.
MSR, right.
This is a truly monumental, multi-decade international endeavor, mainly NASA and the European Space Agency, ESA, aiming to bring back precious Martian soil, rock, even atmospheric samples back to Earth.
So we're talking about bringing actual pieces of another planet home. Sounds incredible, almost sci-fi, but it's currently caught in a very real bind, isn't it?
It is, yeah.
This incredibly ambitious mission is facing some, significant headwinds, ballooning costs, a timeline that's just way too far out, and even real threats of cancellation.
It's true. The stakes are incredibly high, not just for the science, but for the future of interplanetary exploration itself. So this deep dive, this is going to be your essential guide to understanding the complexities of MSR. We'll unpack the core problems, reveal why these samples are so vital for science, and delve into this sort of unofficial space race that's heating up.
An unofficial race. Interesting.
And most interestingly, perhaps, we'll explore the innovative solutions now being proposed by private industry to potentially rescue MSR. Pull it back from the brink.
Right. We've been poring over recent news, expert analyses, and even some really detailed company proposals to give you a comprehensive distilled picture.
Trying to cut through the noise.
Exactly. Think of this as your pathway to quickly grasp not just the intricate dance of interplanetary missions, but also the evolving landscape of how major science gets funded and, executed these days.
Yeah, how things get done.
So let's start right with that rock and a hard place situation you mentioned. The initial blueprint for MSR from NASA and ESA, it sounded incredibly ambitious. Helicopters, multiple robots. What were the specific choices or complexities in that original vision that led to such astronomical price tag?
That's a key question. The original vision was robust, yes, absolutely designed for maximum redundancy and scientific return, but it came with an estimated cost upwards of $11 billion.
$11 billion, wow.
Yeah, and that combined with a projected sample return date of 2040, well, NASA leadership deemed that unacceptable.
I can see why. 2040 is a long way off.
It is. The sheer number of launches, landers, unique vehicles, all the different parts involved in that original sequence, they contributed significantly to that huge figure.
$11 billion in a 2040 return date.
Yeah.
I can see why NASA leadership would flag that. So what has their direct response been? What are they doing about these concerns?
Their response has been to kick off a series of studies, both internal and external, specifically focused on finding ways to drastically cut those costs and, crucially, shorten that timeline.
Makes sense.
There's an ongoing comprehensive review right now by the MSR Strategy Review Team. It's chaired by Maria Zuber, who's a planetary scientist at MIT.
Okay.
And NASA anticipates delivering updates on their revised strategy sometime in the first quarter of 2025, so relatively soon.
And it's not just budgetary pressure, is it? We've heard about significant political headwinds, too.
Oh, absolutely.
The Trump administration's 2026 budget proposals, for example, actually threatened to cancel MSR entirely.
That's right. The Office of Management and Budget even suggested that, maybe a future human mission to Mars could bring samples back instead.
Which sounds like kicking the can way down the road.
Yeah.
How significant is this political pushback?
It's incredibly significant, and it has certainly alarmed, bipartisan groups in Congress and top scientists. They argue that canceling MSR and just waiting for a human mission would be a major step back, basically, for U.S. space leadership and for science.
Right.
It essentially means punting on fundamental science for potentially decades, and there's no guarantee that human missions would prioritize or even, effectively conduct the kind of scientifically driven sample return MSR is designed for.
That really makes the urgency even clearer, which brings up a fundamental question. Why are these samples so crucial? What's this scientific treasure hunt all about that justifies such a huge effort?
The driving objective, the really big question that scientists are desperate to answer, is truly fundamental. Did life ever exist on Mars?
The ultimate question.
Exactly. And bringing samples back to Earth provides the best, probably the most definitive way to search for those signatures of life, or biosignatures.
And NASA's Perseverance rover is already on the job, right?
Yeah.
It landed back in 2021 and has been busy collecting samples.
That's right. Diligently collecting. I think it's up to 21 scientifically selected samples from Jezero Crater now.
Jezero crater. What's special about Jezero? What specific features or geology make it such a prime spot for these crucial samples?
Jezero crater is a fantastic choice because evidence strongly suggests it's an ancient lake bed and river delta.
Ah, water.
Precisely. Those environments are excellent for potentially preserving biosignatures, if they ever existed. And Perseverance has collected a really diverse suite of samples.
Like what kind of diversity?
Well, you've got sedimentary rocks, which are ideal for trapping evidence of ancient life. Then there are igneous rocks, which can tell us about Mars's early planetary evolution and help us date things precisely.
Okay.
And also regolith, basically soil and broken rock, which gives broader context about the Martian landscape, both locally and maybe even globally. That diversity gives us a more complete picture, you see.
So, okay, we have these diverse samples being collected. Why is bringing them back to Earth so critical? Why can't Perseverance just analyze them right there on Mars with its instruments? Wouldn't that be, I don't know, a lot simpler?
That's a really key distinction. While Perseverance's instruments are incredibly sophisticated for a rover,
State of the art for Mars, yeah.
right, but they're still limited by mass, power, and size constraints you just can't get around on a rover mission. Bringing samples to Earth lets us use state-of-the-art laboratories, instruments that are vastly more powerful, bigger, more sensitive.
Labs the size of buildings, not shoeboxes.
Exactly. We can get vastly more information at much higher resolution using techniques simply not possible to package onto a spacecraft heading to Mars.
Okay, that makes sense.
Plus, it enables worldwide participation. Hundreds of scientists, investigators all over the globe can study these samples for years, even decades. It maximizes the scientific return and allows for new techniques, things we haven't even invented yet, to be applied later on.
That long-term scientific yield, like you mentioned with the Apollo missions, the lunar samples are still giving us insights decades later. That really underscores the value.
It does. It's the gift that keeps giving, scientifically speaking.
But is that long-term payoff often overlooked when mission costs and timelines start to balloon, especially with political pressures for more immediate results?
It can be, unfortunately. Budgets and politics sometimes focus on the short term, but scientists are really clear on this. MSR is considered one of the highest priorities in the Science and Astrobiology Decadal Survey for 2023-2032.
And that decadal survey, that's like the scientific community's roadmap, right? Their consensus.
Exactly. It sets the top goals for NASA's planetary science programs for the next 10 years. And beyond just the search for life, these samples have broader implications. Understanding planet formation, evolution, Earth's ancient rock record is pretty limited, so Mars offers a unique window.
Right.
And they're also crucial for preparing for future human missions. We need to study potential health risks from Martian dust and, well, demonstrate we can actually do a round trip, bring something back safely.
While that scientific promise is immense, and scientists are clearly deeply invested, the urgency around MSR isn't purely academic, is it? There's another race unfolding, a kind of red planet race with significant geopolitical stakes.
There absolutely is. China has a parallel effort, their Tianwen-3 mission.
Tianwen-3.
Yes. And their aim is to retrieve samples around 2031, with launches planned around 2028, so potentially sooner than the revised MSR timeline.
And their goal?
Their primary scientific goal is also explicitly stated as searching for signatures of life on Mars. It directly mirrors the U.S.-led effort.
Interesting. It seems like there might be a different philosophical approach to the how of sample collection between the two nations, though. NASA and ESA focus on this scientifically selected suite, whereas China's approach has been described, maybe unfairly, as more of a grab bag. What's the practical difference in scientific value there?
Well, the NASA-ESA approach, which learned lessons from the Mars Pathfinder mission back in '97.
Right, Sojourner.
Exactly. That approach is highly strategic. Perseverance is carefully collecting samples from diverse geologic spots in Jezero, prioritizing bedrock, looking for locations most likely to preserve ancient biosignatures. Pathfinder's grab bag of just loose rocks nearby turned out to be less scientifically valuable for detailed study.
Oh.
Details on China's Tianwen-3 approach are, well, admittedly skimpy at this point, so there are questions about whether it will be more like a Pathfinder grab bag from a single site, or if they'll aim for a more diverse collection strategy. We don't fully know yet.
Given these differing national approaches, how does that impact what people call the scoop debate? I saw a quote from Bruce Tchaikovsky, a prominent planetary scientist, saying something like, any sample is better than no sample, but what's the real difference in scientific value between that carefully selected suite and just a grab sample?
The difference in scientific value is potentially immense. I mean, Sure, any Martian sample brought back would provide some new data. That's true.
Better than nothing.
Right. But Perseverance's carefully chosen suite from Jezero is, as Joukowsky also said, way, way better for answering those specific high-priority questions about Mars's past habitability and potential for life.
So quality over just quantity or speed.
Exactly. The competitive aspect, who gets samples back first, then becomes less about a purely scientific race because the type of sample matters so much and more of a political question.
All right.
The timely return of these specific MSR samples is directly connected to the U.S. maintaining its position of leadership in planetary science and space exploration. Delaying MSR significantly could, in fact, mean conceding the first Mars sample return of any kind to China. And that has significant implications, for future collaborations, international standing, that sort of thing.
The stakes just couldn't be higher then, not just for groundbreaking science, but for national prestige, leadership in space. So just as MSR seemed to be at its lowest point, maybe facing outright cancellations. Who stepped in? Maybe unexpectedly, or for some, predictably, it's the forces transforming the broader space industry, offering a potential lifeline. What's NASA doing now to engage this new space economy?
Well, NASA has openly acknowledged that the original plan is just too expensive and too far away. No ambiguity there.
Refreshing honesty, maybe.
Perhaps. So they've proactively shifted gears. They are actively seeking innovative designs from the whole community, academia, industry, and specifically soliciting architecture proposals from private companies.
Okay.
The goal now is clear. Return samples in the 2030s so much sooner than 2040 and at a dramatically lower cost, lower risk, and lower complexity.
And one of the most eye-catching proposals, the one making headlines, comes from Lockheed Martin. They put forward an offer for a firm fixed-price solution for under $3 billion. That is a massive reduction from NASA's old estimates of $7 to $11 billion.
It's a huge reduction.
What's the significance of that firm fixed-price commitment? That sounds different from usual government contracts.
That's a crucial detail, yeah. A firm fixed price means Lockheed Martin isn't just giving an estimate. They're committing to deliver the capability for that price. They essentially absorb the risk of cost overruns within the scope of the contract.
Okay, so they're putting their money where their mouth is.
Basically, yes. It's a massive shift from traditional cost-plus government contracts, where cost overruns are often covered by the government. It signals really strong confidence from Lockheed in their streamlined approach.
And what is their approach? How do they plan to cut costs so drastically?
Their strategy really focuses on leveraging existing flight-proven designs wherever possible, streamlining operations, managing risk differently, and reducing the amount of sort of traditional government oversight.
And they have a strong track record in this area, don't they? They're not new to Mars.
Absolutely not. Lockheed Martin has incredibly deep, proven heritage. They've built, I think, 11 of NASA's 22 Mars spacecraft. And they designed and built spacecraft or return capsules for all 3 robotic sample return missions so far, Stardust, Genesis, and most recently, OSIRIS-REx, which brought back asteroid samples.
Right. OSIRIS-REx was a huge success.
Exactly. Plus, they operate critical Mars orbiters right now, like MRO, MAVEN, and Odyssey, so they know Mars operations inside out.
So what are their key design changes for MSR that allow for this lower cost?
Their proposal reflects this focus on efficiency and heritage. They're proposing a smaller lander, building directly on their InSight lander heritage, a design already proven on Mars.
Using something already built and tested.
Exactly. Cuts down development time and risk massively. They're also proposing a smaller Mars ascent vehicle, the MAV, which is the rocket to launch samples off cars, and a smaller Earth entry system to bring the samples home. Smaller, simpler, leveraging proven tech.
And Lockheed Martin isn't the only one in the game, right? You mentioned others.
Yeah, that's right. We've also heard Rocket Lab put forward a cut price proposal. Details are maybe a bit scarcer publicly, but it shows it's not just one company seeing an opportunity here.
It really highlights how this whole new space economy is transforming the field, doesn't it? We've seen private funding actually surpass public investment in space recently.
It's a fundamental shift.
Yeah, this isn't just about more money. It feels like it's redefining the very DNA of space exploration. How is this market logic, this competition, this focus on speed leading to such dramatic cost and schedule reductions? Is it just cutting corners?
That's a fair question, but it's more complex than just cutting corners. What's truly revolutionary about this new space economy, I think, comes down to three interconnected pillars of innovation.
Okay, three pillars.
First, there's technology innovation. This includes both incremental stuff like using commercial off-the-shelf components, COTS parts. Remember the Ingenuity helicopter on Mars? It used basically a smartphone chip, 20 times cheaper and more powerful than typical space-qualified chips.
Right. Amazing.
And it also includes truly disruptive innovations, the obvious example being SpaceX's reusable rockets. Game changer.
Okay, so tech is one. What's the second?
Second is business innovation. Things like vertical integration companies doing more in-house. Scale production, building lots of something, like Starlink satellites drives down unit costs. And service-oriented models like NASA's Commercial Lunar Payload Services Program, CLPS.
The LPS, right, where NASA buys a delivery service to the moon instead of owning the whole mission.
Exactly. NASA becomes a customer, not the project manager for everything. Buys service.
Okay, tech innovation, business innovation, and the third pillar. This sounds less about hardware, maybe more about mindset.
The third is cultural innovation. And yeah, it's about mindset. It involves a greater openness to risk and embracing iterative development, often called agile methodology.
Agile, like in software development.
Sort of, yeah. Think of it as moving away from the traditional plan everything perfectly for decades, build it once, hope it works approach.
The waterfall model.
Right. Moving towards rapid prototyping, building, testing, learning from failures quickly, and adapting designs on the fly. This is a stark contrast to the often very risk-averse waterfall approach common in traditional big space missions.
So fail fast, learn faster.
In a nutshell. And what's truly transformative about these three pillars, tech, business, culture, isn't just their individual impact. It's how they interconnect and create this compounding, almost exponential effect.
The virtuous cycle.
Exactly. It allows these private entities to iterate, to innovate at a pace that government agencies, with their different structures and mandates, often just can't match. It fundamentally alters the risk profile and, frankly, the accessibility of doing complex things like deep space missions.
And the implications for science itself.
Potentially profound. This new paradigm could lead to cheaper, faster, and maybe more frequent scientific missions. Imagine being able to respond more quickly to new discoveries or emerging scientific questions. It could foster a whole virtuous loop of discovery. More missions, more data, more questions, leading to more missions.
So bringing it all back, what does this all mean for the fate of Mars sample return specifically? We've covered the critical state of the mission, the huge scientific value of those Martian samples, the intensifying global competition, and now this exciting potential lifeline from private industry in the new space economy.
Well, it connects directly back to you, the listener, and your journey of understanding these big shifts, because this isn't just about rocks from Mars, is it?
No, it feels bigger.
It really is. It's about the very future of how we explore the universe. It's about the pivotal role of innovation, not just technological, but business and cultural innovation in overcoming challenges that seem insurmountable. And it's about humanity's relentless drive, to answer our most profound questions about our place in the cosmos.
Yeah.
It really illustrates how these immense challenges, like MSR hitting this wall, can actually spur truly revolutionary approaches, necessity being the mother of invention writ large across the solar system.
So maybe a final thought for you to ponder. Consider this. If the sheer necessity of saving a mission as ambitious and scientifically vital as Mars sample return forces us to fundamentally rethink how we approach space exploration, pushing us towards these more agile, more cost-effective, perhaps risk-tolerant models, what entirely new frontiers of scientific discovery might suddenly become accessible. Frontiers that we couldn't even really dream of tackling under the old traditional paradigm.